Hey there, and welcome to the stream. I'm your host, Meg, uh, and this is my first time streaming on the virtual coffee platform. So bear with me, please. um, Today, I'm going to be live building a Rust program. It's a guessing game, and it's a walkthrough for following along with the Rust programming language book. This is all part of our, this is all part of our Rust learning cohort. And yeah, it's going to be a good time. But first, we are going to talk a little, get to know each other. And I'm going to figure out this streaming thing a little better. Like I said, bear with me. Hey. If you're out there watching, please write in the comments and let me know, because I just want to know. I just want to know who's out there watching. Tell me who you are, what's your name, where you're from. Check in, say hey. I got a question for you. Give me a second to get it up, because this is going to blow your minds. First off, why are you here? What's attracting you to Rust? Why are you watching today? It's okay if the answer is you have nothing better to do. That's totally fine. I won't be offended. If it's, oh, I want to learn Rust, great, because that's why I'm here too. The second question we have today is, I'm going to put it up. Oh, hey, Lex from Nashville. Thanks for joining us. So usually, if you don't know what virtual coffee is, let me take a minute to explain. It's an awesome online community. Check us out at virtualcoffee.io. It's made up of tons of people who are into tech, and we get together, we talk twice a week about tech-related things. Sometimes the conversation strays a bit, but that's okay, because we're all humans. And we just share our knowledge and our love of the industry. And during these conversations, we separate into smaller breakout rooms. And in the beginning of each session, when we do introductions, we have a random intro question that everyone answers. So I'm going to posit a random intro question to you that I want all you to answer in chat. Also, if you feel comfortable, let us know your name and where you're from. The intro question today is, would you rather have to communicate solely in baby talk, or always speak like you're reading a telegram? Things to consider when you gotta go boom boom, or ending every sentence in stop. So Yeah, think about that one. Uh, for me, I think, I don't know. Would I rather always have to talk like a baby or always speak like I'm reading a telegram? Um, Let me think. You are now live joining the virtual coffee Rust learning cohort live project build. Stop. Thank you for joining me. Stop. This message was sent for 2 cents. Stop. Or I want to press the keyboard to make the project go, to make the guessing game go. Hmm. No, I'd rather do the second one. But I appreciate that Kirk would rather do baby talk for the situational comedy that it would provide. It seems. Oh yeah, Lex says, "Imagine talking like a baby to your boss, though." Can baby please have a ways? Baby do really good at job. Um, the Kirk comes back with, "That's how I talk at stand-ups anyway. Config no work gives my head big ouchie. Gonna cry." So I guess it depends on where you work, huh? Um, and hey, Ethan, thanks for joining. For live closed caption, I believe it's available through the service you're using, whether that be YouTube or Twitch. Um, this, honestly, I came up with the idea of live streaming this 2 nights ago and set it up with the help of the lovely Lex just an hour ago. So I cannot answer that for you today. But I can look into it if this goes not horribly and I decide to do it again in the future. Um, let's see what happens. Uh, cool. So let's get on with it. Best laid plans a lot of times don't come to fruition, which was me getting Rust installed on my computer before I started live streaming. That didn't happen. So guess what we're doing today? The whole shebang. I figured, hey, you know what? If someone's tuning in to watch me build a Rust project, then they're probably interested in, a lot of stuff with Rust. So watching an installation probably wouldn't be the worst thing, right? I don't know. So yeah, we're gonna go with that. Let's see. Okay, I set up another banner. Okay, getting a hang of this, y'all. Oh, and okay, I think I can do this. Yes, there we go. Andy E just joined. He is my lovely co-lead in this journey. Andy and myself are doing this, organizing this virtual coffee Rust learning cohort. And the scrolling thing that I made at the bottom is a link to our GitHub discussion board in the virtual coffee organization. That is the base camp, basically, for this whole learning cohort. Encourage you to go visit, check it out. That's where what I'll be using today, where you can find the resources for all that nonsense right there. What I am going to be using today is the Rust programming language book and Rustling's exercises for a little bit, but then we're gonna do the live build. So, okay, I'm going to share my screen, and hopefully this won't completely blow up. Let's see. Let's do that. Yay! Okay. Okay, so far, so decent. There we go. Let me just, okay, cool. Great. I'm telling y'all, bear with me. Oh, by the way, my sincere apologies for anyone who joined and I didn't introduce my cat is actually sort of hidden behind. Let me just real quick. There we go. Unhidden. But this is Pip. She's my co-host for this stream today. She will be doing the heavy lifting. As you can see. There we go. Back to the topic at hand. Okay, so we have here we go. The Rust Learning Cohort. Oh, I just remembered. I can type back in the discussion thingy. Cool. So I'm going to post a comment. This is the DC GitHub discussion for Rust Learning Cohort. Woohoo! There we go. Sent. I also have oatmeal here. I know it's not really great to eat while you're live streaming, but I'm unconventional. Y'all are just gonna have to put up with it. Thank you, Techie Engineer 5, for pointing this out. I shall increase my text size right now. Oh, duh. How is that? Is that better? I hope so. Okay, great. So this is our Rust Learning Cohort. Our primary resources, like I said, the Rust programming language book and the Rustling's exercises. Today, I am getting started, setting up my editor, installing Rust and Rustlings, and programming a guessing game. Woo! Let's do it. Okay. So in getting started, Did that just zoom in for that one individual page? Oh my goodness. Okay, it did. That's all right. Let's move that here. Okay. So I have a Mac, and that's what this installation will be on. Um, if you don't have a Mac, sorry, I don't know. We'll figure it out. Uh, hello, IU. Um, oh, okay. Could change it in system settings. Uh, so we're going to download Rust through RustUp, a command line tool for managing Rust versions, associated tools. Cool. We need the internet for the download. Whoa. Okay. Well, I got that because I'm talking to you now. So, um, this is for the latest stable version. Did you know that Rust, they release new stable versions every 6 weeks? Like clockwork. That's like, whoa, you know? Uh, that's pretty crazy to me. Anyway, um, let's see. So command line notation. They show commands used in the terminal. Terminal and um, command line interface, that's those two terms are used interchangeably a lot, like CLI, command line interface. Um, you get used to it the more you see it. So lines that you should enter in the terminal all start with a $sign, but you don't have to type that. So copy from there over, not the $sign, or just, that easy little copy setting there. Uh, let's see. Oh, in PowerShell examples use a greater than sign. What do you got here? Um, so I have something open, but when I install things, I usually CD up to my home directory. So pwd is a command that shows you where you currently are. And CD stands for change directory. I made aliases in my terminal that when I have CD with nothing in it, it just goes whoosh to home. And C is short for clear. So when I press C, it just clears everything out. So I'm going to enter that command. And that's not helpful. Look, when I copied that, it copied the $sign in there. So I don't, yeah, that's not really a great feature. That's a note. That's a note, y'all. The command downloads a script, starts the installation of the RustUp tool. Let's see what happens. Hopefully it does what it says it's going to. Woo! Hey, look at that. Welcome to Rust. So this is nice. It tells you like what to expect and everything. You also need a linker. program that Rust uses to join its compiled outputs into one file. Is likely you already have one. If you get linker errors, you should install a C compiler, which will typically include a linker. Oh, okay. On Mac OS, you can get a C compiler by running xcode select install. If you have a Mac, you're very familiar with this line because you have to run it like every time you update your system, or like when you have to run it like so much. It's so annoying. Linux users should generally install GCC or CLang according to their distribution's documentation. So this is nice that this shows you what to expect. Oh, I'm going to press 3 to cancel the installation because I just realized that yeah, the text here is very small too. So let me change that. I have to go into my settings and do the darn thing there. Let's do, whoa, hey. Ugh, ugh. I don't know why. It's like, hey, we're going to make your text bigger, but also everything else too. Okay, okay, cool. There. Now we're all happy. Okay. Like I said, first time live streaming on Virtual Coffee. Thank you for bearing with me. You're all awesome. Okay. So it's great that they guide you through, tell you, yo, this is what's up, man. But what's super important is reading what actually is spit out here, because this is what they're telling you. Hey, this is what's actually going to be put on your computer. Because as much as this is great, who knows when the last time this information was updated? This is what you're getting today and now. They're like, this is where we're putting this. Hey, rust up metadata toolchains will be installed in this rust up home directory, which is mgut. Hey, my last name Gutshaw. So hey, Gutshaw, mguts. I love it. And this is a pretty typical configuration. This can be modified with the rust up home environment variable, which is also pretty typical. They have cargo home directory located at mguts.cargo. Can be modified with cargo home environment variable. And then these commands are going to be added to the bin directory. This is nice. They're saying, hey, this is where the commands are added. This path is going to be added to your path environment variable by modifying the profiles located here. So I use Z shell. So this is the one that really matters, but that profile covers all your shell environments, no matter what. Bash was historically used by Mac until a few years back. I forget which edition it was. Bonus points. Sorry, I moved the stream thing over to my laptop. This is my monitor with my camera on top. So bonus points if you know what Mac update changed the default terminal from bash to Z shell, because I sure as heck can't remember. And then, hey, look, you can install anytime with that command. So if you're like, Rust sucks, man, I tried it and I'm just like, ugh, I hate this, then that's how you do it. So this is telling, let's see. These are the installation options. This is saying, this is like, oh, look at Lex in there, teacher's pet. No, just kidding. I'm not a teacher. I'm learner with all of you. Public learner. This is saying 86 by 64 Apple Darwin, blah, blah, blah. I'm not exactly sure what I think. I have a hunch, because right here, so I have this processor set to i386. I have my shell running in Rosetta mode, even though I'm running on a M1 Mac, because of work. Like some stuff I need for work isn't compatible with the M1 chip. So instead of running on ARM, I have it running on the legacy version, which is called Rosetta mode. I am curious to know, please, folks, post in the chat if you have installed Rust yourself on a Mac M1 chip. Does this say anything about ARM in here? Because that would be interesting. And then we can customize, we can just proceed as is. I want to proceed, but real quick before I do, I'm gonna list files. So how I was saying that these installation locations are pretty typical. This is, like I showed you before, my home directory, users/mguts, and I have Ruby installed. So I have a .rubies because I have different versions of Ruby. And yarn right here. There's gem is like Ruby's library packages. That's the equivalent of cargo to Rust. Is there anything else in here? I think like Java, maybe this is their kind of, oh, here we go, like NVM, node version manager, and then the package manager right here. So once I hit yes, proceed, and now it's gonna do its thing. That will be added into the list. We shall see. Oatmeal break. So what's up, guys? How's it going? By the way, I didn't tell you, I'm in the Philly area. It's rainy. Damn. Okay, wow. That was a lot faster than I thought it would be. I still have a lot of oatmeal left. I'm hungry. Look. But Rust is installed now. Right. Timeout reading Rust C version. That would be, I don't know, it's green. So I'm taking that to be a good thing. To configure your current shell, run source home cargo env. So real quick, I'm gonna type ls. ls is just listing all the things inside this folder. So now we see rust up, we see cargo. Woo! There it is. Bing, bang, boom. And let's do this to configure current shell. Do I want to? Oh, hey. Thank you. Thank you, Lex, for letting me know my face is in the way. I got a big head, so. There we go. Now you can see everything and my face. Okay. Aw, you know what? Just real quick, just so everybody knows. Thank you. Let's do this. Let's see what happens. I'm just gonna run this source home cargo env. All right, it's configured, I guess. I'm not sure. It says restart your current shell. So usually after you install something, you do want to just straight up quit your terminal and then open her back up and be like, hello, good morning. It's a brand new day, isn't it, terminal? And then it's like refreshed and ready to go. You also need a linker. A linker. Okay, well, now we can check if Rust is installed correctly. We should see the version number, commit hash, and commit date for the latest stable version that has been released. Let's find out. Woo, woo. Oh, yeah, look at that. 02, 04, March 2nd. So then, okay, I don't want to show you all my life. So calendar. Let's go. Okay, here we go. So 2-4, February 4th. So 1, 2, 3, 4, 5, 6. The 17th is when the next release is going to be. Sweet. What a lovely, simple calendar. Look at this. Look, you know what? Just plug in this site because sometimes you just need to know what time it is somewhere. Just gonna keep that going. Uh, cool. And then, what time is it? It's morphin time. Whoa. Also, let's just print out the path. Let's just see what's up. They release Rust releases stable updates every 6 weeks. I can tell you. Hey, okay. This is in response to Lex's question. Is Rust releasing new minor releases at that cadence or a major? And stability without stagnation. That's like their motto. Um, they do a train schedule, is what they call it. So nightly, beta, and stable releases. And I'm going to post that link in here because I didn't know what a train schedule was until I read this, and it's actually pretty interesting. Okay, so harkening back to uh, the intro question. Here we go. I'm going to show it again for people who joined a little late. If you joined late, feel free to answer the intro question and introduce yourself. We're on a choo-choo train schedule with Rust, and there's a nightly, a beta, and a stable. So every night they have a new release. Choo, choo, choo. And then every day is release day. And so then the oh, you know what? I got it wrong. So every 6 weeks is the beta branch. So then every 6 weeks, the nightly train goes to the beta station. And when people want to test new features, they use the beta train. Choo, choo, choo. And then it still goes the nightly choo choo train. And if then a regression, oh, that's a big word, is found in the beta, they fix it and apply it to the nightly release. Oh no, I was right. Okay, I was right. And then 6 weeks after the beta, it's time for the stable. So the beta goes to stable, and then another beta is cut from the nightly. So that's how it goes. Like, and then if a regression is found in stable, which hopefully not because it's supposed to be stable by then, that goes back to beta and nightly. So Rust releases every 6 weeks like clockwork. And then they have like big releases like what is it? I forget what they call them, but they roll like a whole bunch of the stable releases into like a large one that, like, if there's a large change or something, or there's just been a lot of changes in stable releases lately, they'll like just kind of make a big deal about it and sum up a lot of the stable releases. So I think it's every 3 years is what they do for like um a new version release. And we're actually due this year in 2024. So, ooh, I feel like the Telegram voice is harder to do. So maybe I'm changing my mind on that. I don't know. Uh, okay. Where was I before this? Okay, cool. Um, Find out how to get in touch with other rustaceans on the community page. Rustaceans, yes. Oh, this is what I was going to do. Echo path. Oh, always a thorough answer. And if I don't know, I will follow up later. Okay, there's a lot of weird stuff in her. But let's see. There should be rust in here somewhere, maybe. I don't know. Yeah, here we go. Cargo. And that's where Pythonistas. Rustaceans is better than Pythonistas. Hot take from Kirk. But if you'll oh, I can't scroll up. If you'll remember correctly, on the installation screen, they said in .cargo/bin is where like the processes live to start Rust and its features. So that's what we want. Cool. And it also includes documentation, which most languages do. Uh, Whoa, damn. It says a local copy so you can read it offline, even though it opens up in HTML. So that's pretty nice. At least you don't have to like read it in the terminal, like like a man page or something. Cool. We're installed. Yes. Okay. Now we've installed Rust, it's time to write your first Rust program. Oh, I didn't install Rustlings. Where where am I? Where am I? Install Rustlings. Let's go here. Oh, look at that. That looks simple enough. Ooh, where do I want to put it though? So I want to put this somewhere. I made myself a little workspace for. Oh wait, why do I have rustlings in here? Okay, let's see what happens. Ah, well, I'm I'm going to delete this out because if you'll notice, it says path rustlings already exist and it's not an empty directory. I don't really, I don't know. I don't know what's happening here, but let's try this again. Yeah. GitHub Copilot time. I do use Copilot, but I'm trying to be careful not to use it as a crutch. I still want to try to troubleshoot things myself. I want to be frustrated still. I want to be able to get frustrated and dive into things because a lot of times I come across things that I wouldn't have learned because I get forced to deep dive in order to figure out what I need to do. Um, Especially when it comes to setup things. And it makes me learn more about my computer system and um, I think that's important as a developer to know your baby. I'm rubbing my laptop right now. You can't see it, but I am. Uh, yeah. Brain food. Thank you for bearing with me, everyone. Cool. Yeah, we're good to go. Well, thank you, Rustlings, for making it extremely easy to install your exercises. Lex is saying that I'm gonna need oatmeal every time I stream. I don't think that would be a great idea, but I don't necessarily think it would be a bad idea. So what I have here is small text, which I need to make bigger. Oh, font size. No, wait. Okay, code. Font. Hey, okay. Let's go 20. Yeah. Is that's not making anything bigger. How? Okay, just pressing Command plus. That's always the way, I guess. I don't know. Okay, let's go back. Go back to what it was. Okay, what I have here is a idea that wait, where are we going? Hashtag oat stream. This is taking legs. I don't know. Techie engineer. Are you Andy too? Who's techie engineer? Sorry. If you don't want to say who, that's fine. But is this good? Do you need me to increase the font size more? I want to make sure everyone can see. I'll keep going unless I hear otherwise. Oh, the window? It doesn't get much bigger. Um, there's a method to my madness. Uh, so what I wanted to share was, here we go. So this is the cohort. I took what is in here um, in the discussion and kind of made it into a repository format because I thought some people may want to be able to adjust it or do whatever they want with it. And um, I made a Meg track uh, so I could take, so I could like, check off my own stuff. So hey, check mark. Woo. Um, yeah, nice. Going to figure out the other stuff later. Uh, and as you'll see, I'm on the Meg track. And that's why I made a Meg workspace because I have a different workspace for the main repository where I go and update the schedule every week and whatnot. Okay, back on topic. So we are where boo. Here we go. Cool. Let's do these real quick and then get to the meat. After like an hour. Um Now that you installed Rust, it's time to write your first Rust program. Okay. It's traditional when learning a new language to write a little program that prints the text, hello world, to the screen. So we'll do the same here. Oh, okay, cool. This book assumes basic familiarity with the command line. So, as an aside, that was one thing with our that was one thing with our creating this cohort, Andy and myself. They actually in the forward here, no, the intro, they say this is probably not great for people here. This book assumes that you've written code in another programming languages, but doesn't make any assumptions about which one. If you're entirely new to programming, you would be better served by reading a book that specifically provides an introduction to programming. So we don't want to be gatekeepy. That is definitely not something we want to do. But we want people to be aware that if this is their first programming language, don't feel discouraged if it's not clicking, because this book is specifically designed for people who already are comfortable with programming. That being said, if anybody feels lost while watching this, please keep that in mind. And also, please put questions in the chat. I am happy to pause and answer anything. to the best of my ability. And if anyone else watching sees a question in the chat and think they can help, please jump in. I am not going to say, you're stealing my show. And if you see me doing something wrong, please let me know, because this is, you just saw me install it on my computer. I have not written anything in Rust yet. And like, I'm really behind in this cohort. And I'm one of the people running it. So hey, that goes to show you. Um so yeah, that was my little disclaimer. Uh cool. Um let's get going, y'all. Cool. Uh I just had like a mental thought, like after words from our sponsors, and then whoosh, it switches to uh this stream is brought to you by, but no, that'd be cool if we get sponsors. Hey, do you want to sponsor virtual coffee? Reach out to us at hello@virtualcoffee.io. I'm pretty sure that's the email address. Find us somehow. Can do this. We'll get your product placement right in here. I sure love Bob's Red Mill oatmeal. It keeps me full and gives me brain food for when I'm live streaming how to write Rust. You can have that for a small fee. Also, if you don't know, join us. Join us. Go to virtualcoffee.com/join. Check it out. All you do, all we ask is that you come to a meeting. It's on Zoom. It's an hour long. We have them Tuesdays at 9 a.m. Eastern and Thursdays at noon Eastern. Come out, see how you're feeling about it, if the vibe is right for you. It's very low pressure. We encourage everybody to participate, with the microphone and have on their camera. But if you're not comfortable with that, totally fine. We definitely have people coming in who don't put on their camera, who don't use the microphone and participate via chat. And whatever works for you is cool with us. Just as long as you follow our code of conduct, then you're welcome. So come check us out, and we can go from there. And yeah, you just join a Zoom meeting, and if you like it, you send your email to one of our volunteers, and you get invited into our Slack channel. And the world of virtual coffee opens to you. And you could become a crazy person like me, streaming at the last minute online. It'll be great. Okay. hide banner. Yes. Okay. There we go. Okay. So let's do this. Start by making a directory to store your Rust code. Let's do. Okay. Rust Learning Cohort Meg. And here is all my stuff. So let's make a directory. What should I name my directory? They say projects. It's kind of boring. Does anybody have a more fun name? I mean, I could go with projects, but the Meg Learning Project, Super Projects. What? Bombastic side eye. Oh, okay. Techie engineer, you got this. Super Meg Learning Projects. Boom. There we go. I love how you took two ideas and just made them infinitely better. Collaboration at its peak. And now we're going to do Hello World. Do they? Okay, what is their. Ah, they do underscores. Okay. Make directory, hello world. Okay, here we are. By the way, if you were unaware of this handy little trick, I use Visual Studio Code for my text editor, and it's little abbreviation for the terminal is code. If you're in a folder and you want to open that in Visual Studio Code, you just type code and then space period, and it's like, oh, where I am right now, open it in Visual Studio Code. Hello world. So yeah, pretty cool. Snake casing. Thank you, Alexis. That's what this is. Underscore snake casing. This like V dash C VC dash Rust dash learning dash cohort. That's called kebab casing. Fun fact for you. Okay. Okay, so we make a new source file called here. Let's rearrange this. Let's make it a little so I don't have to keep going back and forth. And it's a little less painful for everyone involved. Usually I use the terminal for fun things like this, but I'll use the GUI graphical user interface. Oh, this has to be highlighted. Fun fact. Thank you. That fact is very fun, Alexis. Screen case. Rusticles? Wait, what? What just happened? We're hearing about rusticles from Kirk, so I'll wait for more information. In the meantime, ooh, main.rs. Look at that. Look at that. Hold on. Main.rs. Bang. Rust icon. Hey, rustables. Oh no. Kirk is just making up words now. Okay. I think he may be responding to my what should I name my project file like 10 minutes too late. This is our new source file, main.rs. Rust files always end in the .rs extension. I can tell, look, it's got this cool little wee Rust. This is the Rust logo. But there is also another unofficial Rust icon. If anyone can tell me in the chat, you get bonus points. I'm gonna get a bit of oatmeal while you're all thinking about that. Lex is saying Mr. Krabs and she's warm. Hello, Christine. Thanks for joining us. We're about to start writing a Hello World program. It's a little crabby crab named Ferris. Ferris the crab. Okay, so if you're using more than one word in your file name, the convention is to use an underscore to separate them, which we found out is called snake case. I'm a snake. I'm a snake. Okay, so, ooh, what's this? Run this code. Whoa, what does that do? Oh, whoa. Okay. So I could copy this and just paste it in, but since I'm learning a new programming language, I want to get the muscle memory down. I want to get the practice of writing. And look, Copilot's trying to take this shit away from me. Bye, Ayu. So you know what I'm going to do? I'm going to turn off Copilot. Because I don't want Copilot spoiling our fun. I knew exactly where I was going. This isn't a stream about Copilot. It's a stream about Rust. Sorry, y'all. Hello, world. Listing 1.1, a program that prints hello, world. Okay. I hope that freaked you out, Lex. Save the file. Go back to your terminal window. Enter the following commands to compile and run the file. So instead of that, I'm going to open up my embedded terminal here. So this is the ARM terminal. Yeah, I thought they were. Those were pitches for folder names from Kirk. Um, Copilot is not free for me. That would be amazing if it were. Okay, so I'm in I'm currently in this directory, like this project directory in my terminal. So let's see. I'm gonna close that out. So Rust C looks like the command main.rs. What's going on? And then /main hello world. Enter the following commands. Let's see. Okay, that worked. So that's interesting why this came up. Um, let's look into this. Okay, so I'm gonna highlight this. Thanks, Lex. Oh gosh, and I just realized that my face is covering. So you know what? Here, I'm gonna open the terminal again. Let me do this. Cohort Meg. Super Meg Learning Projects. Hello World. Okay, so this is. I'm trying to look at the screen and figure out where we are. Okay, I think I have this set up now. Thank you for bearing with me. Okay. Now, that was in a terminal that's running ARM. So I actually, let's look at this. Um, I have a suspicion. Okay, cool. So session restart. Okay, so you see how this terminal, I said earlier, it has the I386. Let me see if I can pull something up without I want to show you all something without here. I'm going to show my beautiful face to you all for just a little bit. Uh, because I want to show you all something, a setting that I have that is responsible for switching between these two, between Rosetta and um, arm, but I need to make sure I'm not sharing anything sensitive at the same time. Y'all know how that is, right? I'm gonna show you that and something else real quick. Let's see. Dun, 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 dun. Okay, I can show you this. Great. Okay. Get ready for your mind to be blown. Okay. So this is a little thing. This is my Z Shell RC, whatever the hell that is. I know there's Z profile, Z Shell RC, and there's something else too, and I can't remember what the heck. It's like Z, yeah, ZSHENV. There's so much stuff. Oh, they're each called at different times, and I looked it up before, and it was a lot. And I'm just like, what? Okay. Anyway, so I have Homebrew installed on both, and this is the main reason why I have it show up as ARM and this one. I should change this to say Rosetta. Because this doesn't make sense for me in like layman's terms. It's like, what is I386? Who knows? But this is like the legacy, whatever, the standard that was used before M1. Was it Intel? Yeah, Intel chip versus silicon. So the path is different. If you'll notice, so Homebrew prefixes this for the Intel chips, and this is for the M1 silicon chips. So that's like a huge difference. And if you don't keep track of where things are installed, your homebrew will be like, what? I don't know. What you huh? I don't get it. So like they have to match up. So this is basically saying like if my CPU is running in like the M1 like it's supposed to, then we're going to print it out. The brew prefix is going to be sent to the bin path or the path like it's supposed to, and we're going to evaluate the um, brew. What is this? Autocomplete, I think. Auto completion um, for this shell environment for this session, basically. And then this is creating aliases. So if I put in this one, I don't know if it's gonna here. I think print that no. Um, but I type the brow alias and it sends back like brew stuff. But let's say okay, I can show like a good example here. So the path here has homebrew, the opt homebrew bin and S bin. For this one, the path, where are we? Homebrew. Rubies, Postgres, local user. I don't know where it went. User local bin. Oh, here we go. Okay, so user local bin and user local S bin here because it doesn't have the word homebrew in it. That's what I was looking for. um, yeah. Anyway, sorry, that was like a tangent. Um, but it's super duper helpful when you have to run things in Rosetta mode or and other things in non-Rosetta mode. And if you want this code, if you're in Virtual Coffee and you want this code, just send me a Slack message. If you're not in Virtual Coffee and you want this code, join Virtual Coffee and then send me a Slack message. um, or you can leave a comment and uh, or actually, let's see, my GitHub, but is it? I think it's yeah, I can make a gist to my GitHub. I think I'm pretty sure something like that. I don't know. Uh, um, it's either underscore or dash. I always forget, but find me on there and I'll put a gist up after this. No, it is not a recruitment stream for Virtual Coffee. It should be though, right? I'm doing a great job. Oh. So that being shown, what I think happened and we will test this theory right now. I'm going to slip back into the installation page and go here. So I just showed you all that these are two different processors on the same machine. I think that weird thing happened when I ran rust main, rustc main.rs. Do it again in case we missed it the first time. I'll pull this down a little now that we got more breathing room. And you see how this other file, like, just what? Like, what? What are you doing here? But then we /main, hello world, woo! I think it's like, what is this? Where is Rust? So I'm going to put rustc version. Oh, it sees that it has it there. Huh. That's interesting. I thought it would be like, what is that? I thought it would ask, where is Rust? So I'm going to delete this file. And go to the same project here. And let's try it here and see what happens. Rust c main.rs. Wow. Okay, that was different. And /main. So let's see. Lex is saying rustc compiles to machine code that targets your hardware, not bytecode. Probably why it's so fast. I don't understand what that means. Yeah, I like this, techie. Explain it like I'm 5, Lex. And granted, just so you all know, Lex is not a Rust station, but she is super damn smart and knows a lot about things. So so we did get Hello World print, which is awesome. So now we have the anatomy. Let's see. Oh gosh. We just had a wild German has appeared in chat. Let's find out. The first piece of the puzzle. These lines define a function called main. Oh, main function special. It's always the first code that runs in every executable Rust program. Wow. It has no parameters and returns nothing. If there were parameters, they would go inside the parentheses. Oh, and this is probably important. I don't know. It's not important, but it's good context to know. I myself am a Ruby on Rails programmer. Like I said, I'm in the Philly area. It's a rainy day, but it's warm. Mm. Um, I work for Penn Medicine. It's a hospital system affiliated with the University of Pennsylvania. And I work with Ruby and Rails code all day, every day. It's amazing. Love it. And I also work with a lot of JavaScript. So this is very JavaScripty in setup. And parameters is like the same type of language that Ruby and JavaScript uses. Okay, so getting back to our explanation. So we're saying Rust C compiles to machine code that targets your hardware, not bytecode, which is probably why it's so fast. And Lex is providing us with this wonderful explanation or analogy. Imagine you're trying to tell a friend how to make a sandwich. You could either give them detailed step-by-step instructions in a language they understand perfectly, like telling them in English, first take 2 slices of bread, then spread peanut butter on 1 slice, blah, 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 blah. This is like compiling to machine code. Or you could give them instructions in a simpler, universal language, like drawing pictures of each step. But then your friend has to interpret each picture before they can make the sandwich. Oh, okay. So this is like compiling to bytecode. Rust C does the first option, gives the computer detailed instructions in a language it understands perfectly. Machine code. This means the computer can start making the sandwich straight away without needing to interpret anything. Man, I'm gonna stick with oatmeal because it's sandwiches. Wow. Oh my gosh. Urine's gonna put holes in my stomach. I think that was a threat. Um, it's always sunny in the hearts of Philadelphians, Jackie. Okay, so how do I let me see. We had a request to put the comments. Oh, awesome. So Lex just jumped into the Twitch chat for Techie. I was trying to find out, but yeah, thanks, Lex. Lex is going to repeat their wonderful sandwich analogy in Twitch for you, Techie. And I starred those messages, so I will write it down and put it in our discussion for everybody to enjoy. So this is just like a product of the compiler then, um, which is interesting and makes me wonder. Okay, what I want to do first. So we already have this information here. So can I just run dot main again without dot slash main again? Yeah, cool. So now what happens if I run rust c main.rs again? Nothing, because it already has that info. And lastly, deleted that. I want to see what happens if I run dot slash main by itself. Now it's in red. It's like, it looks like it's not going to do anything. Huh. Okay. So okay. I had an aha moment. Ah! Aha! Pip! No, no. No, she doesn't care. Hold on. You care? Nope. Doesn't give two flying you know what's. Okay. So this is what's happening. Rust C main.rs like like Lex explain. This is a team effort, y'all. I wouldn't be here today without you. Rust C gives the computer detailed instructions in a language it understands perfectly. Those instructions are in this file here, right? Without that file, it doesn't know how to print hello world. So it's not going to do it. It's like, what? What's that? Such mean? Huh? This is an executable file. That's what it's called in Ruby. I don't know if there's a special name for it in Rust. And I'm starting to travel too low. Oh, okay, there we go. So now that file's back, guess who's back? Back again. Main is back. Tell your friends. I don't know if you can see. It's really hard. Let's see if I can. I wish I could do like a. Hold on. No. What? What? Sorry. Okay. I'm gonna do a screen capture of this and see if I can zoom it in. Oh, no. Wait. Yeah. Yes. Yes, my pretty. Okay. So I have this cool thing called Fig. It's a plugin for my terminal. Shout out Bogdan, another VC member, told me about Fig like years back. So this is just like the word main that I typed in. This, it has like a little icon next to it. And that is actually targeting this file. Like it's saying, look, this is an executable file that you can run. And that's coming from here. And then this is referring to this file in here. So like Fig kind of digs into where you are and auto populates things based on what you're typing. So this is just plain text, the executable file, and the Rust file. But yeah, cool. Main, hello world. Hello world. Look who gets it, world. Meg does, world. So, okay. Whoa. um, nice. All right, so where were we? Breaking it down. Maine is the first. It's a special. It's special. Maine's so special. Um, always the first code that runs in every executable. They use that word too. Okay. Uh, executable Rust program. Here, the first line declares function name main, no parameters, and returns nothing. The function body is wrapped in curly brackets. Rust requires curly brackets around all function bodies. It's good style to place the opening curly bracket on the same line as the function declaration, adding one space in between. Yes. No. Rust format. So this comes automatically with the so this comes automatically when you install Rust. It's a standard formatting tool. Like there's no go in and configure to your liking. Like the Rust community's like, let's just do one. Let's just pick one format and everybody do that. And that's pretty cool because you don't have to worry, you don't have to argue over like styles and stuff. So yeah. And then the body of the main function holds the following code: print ln exclamation point. Hello world. This line does all the work in the little program. It prints text to the screen. There are 4 important details to notice here. Okay, so 4. First, Rust style is to indent with 4 spaces, not a tab. Wow. Wow. Interesting. Okay. Fixed. Second, print ln exclamation calls a Rust macro. If it had called a function instead, it would be entered as print ln without the exclamation point. Okay, we'll get to macros in chapter 19. Using an exclamation means you're calling a macro instead of a normal function. Macros don't always follow the same rules as functions, okay? The hello world string. This is an argument to print ln. The string is printed to the screen. So what we discussed earlier, what I regurgitated at you earlier, this, it's in the parentheses. So we know it's a argument or parameter. Those are used interchangeably a lot. I believe parameters are variables that are waiting to accept values, and arguments are the values themselves. I'm pretty sure that's the difference. Don't quote me on it. Actually, you know what? Just forget what I said. And then fourth, we end the line with a semicolon, which indicates this expression's over. The next one is ready to begin. So JavaScript-y in that way. Although I'm sure there's other languages that use semicolons to end. The one that I know that uses semicolons to end is JavaScript. Okay, compiling and running are separate steps. Huh. What does that remind you of too? JavaScript. You just run a newly created program. Let's examine each step. So this is where we're getting into it. Before running a Rust program, you must compile it using the Rust compiler by entering the rustc command, passing it the name of your source file. If you have a C or C++ background, you'll notice this is similar to GCC or CLang. Okay. After compiling successfully, Rust outputs a binary executable. Guess who's back? Back again. Main is back. Tell your Rust hello world program that it can print out the line again. Okay, I'm done making a fool of myself. It's like, no, I'm not. So sweet. This is what you see on Linux and Mac. 2 files. The PowerShell. Oh, PowerShell needs 3 files because it's got the power. Okay. So we have the main.rs and then main. And then, cool. Here we go. If you're more familiar with a dynamic language such as Ruby, Python, or JavaScript, you might not be used to compiling and running a program as separate steps. Rust is an ahead-of-time compiled language, which let's see. Which is the universal, the second option. So Rust is giving the sandwich instructions wait, no. Shush, Meg. I'm gonna just shut up. So you can compile a program and give the executable to someone else, and they can run it even without having Rust installed. That's pretty cool. So this has nothing to do with sandwiches. That makes sense because if I took this hello world file as it is now and sent it to somebody, all they have to do is type this dot slash main because the information's already there. That's really, really neat. I know, Lex. I need to calm my ass down. Woo! Okay. Hello, Cargo. Rust build system package manager. Most rustations. That's me. Use this tool to. Okay, I swear I said that's me. And I heard someone go, mm-hmm. And I thought it was my cat. It might be my tenant upstairs. Sorry. I need some more oatmeal. I'm fading from hunger fatigue. mm. So Lex points out what I said before. If I shared this hello world file with someone, it would only work if they have the same processor architecture as myself. Because the compiler targets hardware. So it's like video games. You can't play an Xbox game on a PlayStation. I stole that analogy. Thank you, Lex. I don't know shit about video games. I mean, I know there's different consoles and stuff. Did you know that Game Boy, like, little known fact, there was a port in the back of like the old school PlayStations where you could hook in your Game Boy and play Game Boy games on the PlayStation. How did we not know this? I don't know. But we should have. You know what? It was a conspiracy by parents. They could give us the Game Boy and we're like, and then they could watch whatever they wanted on TV. Because if we hooked into the back of the TV, then it's gone. Okay. Back to the topic at hand. Well, I at least blew one person's mind. Thank you. Real quick. Just reminding you, this is a virtual coffee stream. I'm part of the Rust Learning Cohort. Myself and Andy E. are organizing it. And you can follow along with our cohort in our GitHub discussion board. Right, I have the link. I have it. Oh, here we go. And I'm gonna put it here. Hey, man, I'm just reminding people what they're tuning into, okay? Okay. uh, yeah, cool. So that's where we are. Let's do this. Whoa, 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 whoa. Uh, so cargo. Most of our stations use this tool to manage their Rust projects because cargo handles a lot of tasks for you, such as building your code, downloading the libraries your code depends on, and building those libraries, or otherwise known as dependencies. Um, we don't have any dependencies in Hello World. So it uses the part of cargo that handles building your code. As you get more complex, you use more cargo. Um, most projects use cargo. So the rest of the book assumes that you're using cargo too. Cargo comes installed with Rust, which we know from earlier today. And let's just double check cargo version. Whoop, there we go. So let's back out and huh. Oh, the browser sidebar. So this uh techie is asking how I got Chrome to look like this. This is actually Arc. It is a Chromium based browser. Arc browser. Check it out. I like it. Um, so cargo new. Hello cargo. That's how we're starting this. And this is reminiscent of Rails' new project name. Uh, there we go. Create a binary application. Hello cargo package. So let's go into there. And let's open up this puppy. Mm, all right. So Cargo creates its files in a directory of the same name as the project, Hello Cargo. So it generates two files in a directory, cargo.toml, get ignore, src with main.rs, and it initialize a Git repository. Da-da-da. Oh, no, Git is a common version control system. Oh, okay. So let's see, open the toml file. What is this? Oh, there it is. Yeah. Tom's obvious minimal language. Um, what was it? Tom, uh, when, what's his name? Tom, sorry, I want to go on a tangent again. Tommel. Tom Preston Warner. That's his name. This guy has made a lot of interesting things, and I got to watch him speak at a meetup one time, and he talked about Tommel. My gosh. Uh, and he said Tom must have a Twitter. Uh, yeah, go away. Tom Preston Warner. Um, yeah, Redwood JS, that's his thing. Just look him up. It's gotta be on there. Um, but he was on a stream and he talked about Tommel and he said his wife was away for a weekend and he had been using YAML and there was just something about it. He's like, I just feel like it's almost there, but not quite. And he just took a weekend and wrote this thing for himself to use. And it caught on where he was working, and some of his friends started using it. And then it just became something that people used. He's like, I didn't want to make a new thing. It just happened that way. And so he's like, yeah, so then yeah. It's pretty funny. It's like you get more than you bargain for sometimes. Um but he seemed like a really cool guy and Redwood JS looks like a very interesting uh JavaScript framework. But, there's a lot of them out there. So take that with a grain of salt. Um anyway, cool. Big use Tommel. So we have info on the package, name, version, edition. Edition is the edition of Rust that we're using. 2021 is the latest. Like I said, they release, so that's what they call them, editions. They released a new edition every 3 years, and it's basically just their um, uh, stable releases, like their 6-week cycle stable releases, all kind of packaged together with highlights on the changes. Version is for this app right here, Hello Cargo. Here we go, more keys and definitions. Let's check it out. Let's see what's going on. Woo, hey. So we could put a lot of stuff. Like if I wanted to be like, I, Neg Gutschall, authored this Hello Cargo app. Yeah. Rust version, so you could get more granular than edition. The minimal supported Rust version. Description, documentation, readme, yeah, license, keywords. Keywords is underrated, I think. Because if you want people to find your thing, whatever you publish, boom, hey. Like fill out all this stuff if you want people to find it. then dependency. Woo. Uh, so that's here too, although it's blank. Here's version requirements. They use Semver. It's here we go. So I'm going to, this is important to know. I'm pasting it in chat. If you are releasing anything, even for your own projects, it's good to try to keep semantic versioning. Yes, semantic versioning, semver. Excuse me. It's good to try to keep up with it just to get in the habit. And if you don't, it's whatever. But definitely it'll come in handy because when you're working, you already have the habit and the practice. But yeah, here's all the info you need to know. So let's see, the last line, dependencies, start of a section for you to list any of your project's dependencies. In Rust, packages of code are referred to as crates. So we don't need any other crates for this project. Oh, but we will in the first project in chapter 2. Woo! Okay. Oh, there we go. There's the 4 spaces. So now we're taking a look here. So Cargo generated a Hello World program. Difference between our project and the project Cargo generated is that it placed it in the SRC directory, and we have a cargo.toml configuration file in the top directory. So Cargo expects your sources files to live inside the SRC directory. Top level directories just for README files, license information, configuration files, anything else not related to your code. Okay, so Cargo helps organize the projects. There's a place for everything and everything in its place. You start a project that doesn't use Cargo, as we did with the Hello World project. You can convert it to a project that does use Cargo. Move the project code into the SRC directory and create an appropriate TOML file. Okay. Now let's look at what's different when we build and run the Hello World program with Cargo. All right. This will be what's different. So I'm going to do before we do this, I'm going to use I'm going to commit initial cargo build. Oh wait, what do they call it? Let's create a new project using Cargo. So initial cargo generation. Initial project generation using Cargo. There we go. Whoop. Bye, Techie. Okay, there. Commit I'm gonna actually, I'm not gonna publish this yet. Uh, how do I cancel this? Boo, boo, boo. Okay. Cool. So it's committed locally. That's fine for now. So I don't know where I want to put it yet. Um, let's see. Now we're gonna do cargo. No, cargo build. Hello, cargo. Unoptimized and debug info. Huh. Okay. So that's different. So there's a lock file. So this is probably generated from the TOML file, if I had to guess. And now we have target. Oh, let's find out what happened. This command creates an executable file in target debug hello cargo. Oh, right there. Rather than in your current directory, because the default build is a debug build, cargo puts the binary in the directory named debug. And you can run the executable with this command. If all goes well, hello world should print to the terminal. Running cargo build for the first time also causes cargo to create a new file level at the top, a new file at the top level, cargo.log. This file keeps track of the exact versions of dependencies in your project. This file doesn't have dependencies, so the file's a bit sparse. You won't ever need to change this file manually. Cargo manages its contents for you. Okay, so you see how, yeah, I'm gonna go here. I don't know if you can tell, but this is kind of grayed out and this is not. This is white. Haha. Git ignore. Git is ignoring the target directory. That's why that's grayed out. So that's also why this one is, when I hover over it, you see it says untracked. It has that U. That's the only one that's like comes up as a change. Since that's how git ignore works. Lex is saying that makes sense. You usually would not want to commit the executable. And I guess this is just affirming that. However, I'm very familiar with lock files, and you do want to commit these. Generate lock file. These are usually the source of truth. So if you mess something up, you can just go grab the last lock file and fix it. um, a lot of times with debug builds, uh, there will be like a whole directory like this that's like kind of looks ghosty, because it's meant for use and development, not your final build, not your production. Um, yeah. So let's check it out. Let's see if we get a hey howdy, how are you? Oh, look at that. Oh, hello. Hello, right back at you, world. Um, ooh, hey. Okay, so we can also use cargo run to compile the code and then run the resultant executable all in one command. So cargo build, cargo run. Let's see. Oh my God. Would you look at that? Using cargo run's more convenient than having to remember to run cargo build, then use the whole path to the binary. Yeah, no duh. Notice this time we didn't see output indicating that cargo is compiling hello cargo. Okay, it figured out the files hadn't changed, so it didn't rebuild, but just ran the binary. If you had modified your source code, cargo would have rebuilt the project before running it. All right, let's give it a shot. Let's do hello cargo. And now we'll do cargo run. Ah, that was quick, but did you see it said building for like a second? Um, and then it went and did that. I'm going to change it back. Now I'm going to do it again. Watch carefully. You'll see it. Actually, I'm going to get my screen capture ready. So in case we miss it. Whoops. Okay, you know what? Just watch carefully because I messed that up. And if you didn't see it, oh well. You're just gonna have to do it on your own. Okay, and let's see. Cargo provides a command called cargo check. This command quickly checks your code to make sure it compiles but doesn't produce an executable. Boo, 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 boo. Checking, finished. That one also said building, like, really fast. Really fast. Okay, why would you not want an executable? Cargo check's much faster than cargo build because it skips the step of producing an executable. If you're continually checking your work while writing the code, use cargo check. Okay, cool. Many Rust stations run cargo check periodically as they write their program to make sure it compiles. Then they run cargo build when they're ready to use the executable. So we're building for release. When your project's finally ready, you can use cargo build release. Compile it with optimizations Oh, you guys want to release this new hotness? Yeah, yeah, yeah. I think so. Cargo, build, release, optimized. Look at that. Unoptimized plus debug info. Optimized. We're ready. It makes your Rust code faster, but turning them on lengthens the time it takes for your program to compile. Yeah, this was 0.09 seconds. This was 1 whole second. I don't know if I can abide by that. um, two different profiles, one for development when you want to rebuild quickly and often, another for building the final program you'll give to a user. So it won't be rebuilt repeatedly and will run as fast as possible. Cargo is convention. Okay, so this doesn't provide a lot of value as simple projects, but it'll prove its worth as your programs become more intricate. All right, cool. Now nearly 2.5 hours in. Welcome to the main event. Programming a guessing game. Yeah. Holy hell. Okay. This is what we are gonna do right now. We're gonna take a 5-minute break. And when we come back, we're gonna do this. We're gonna program the shit out of this guessing game. Yeah. And I don't know. We'll see. We'll see what happens. Because Hello World is one thing. I don't know what is gonna happen with this, but stay tuned. Find out. Um, let's see if I can set a timer for 5 minutes. So yeah, that's my be back in 5 minutes. Ooh, I like this. Oh God. Okay. I'm on YouTube and there's like a 5-minute timer and it has like people, it shows how people like drop off, right? Like the people watching. And it's just like so many people watched for like 10 seconds and then left. It's like, wait, 5-minute timer, relaxing music with ocean waves. That's the name of the video. What did you think you were getting when you came here? Like, I don't, what? Oh my God, that's funny. Um, uh, Uh, okay. I'm going to. Oh, I have to. Oh, God. Hold on. This is. What is happening here? What is happening? Theater mode. Can I do this? Can I go full screen? Oh, yeah. All right. Be back in 5. Stay tuned. I'm, I'm gonna. I'm gonna make it cool and fun. Yeah. Yeah. And we're back. Hey, that was a quiet, relaxing stream from TikTok countdown timer. Thank you. If you would like a 5-minute timer, oh, relaxing music with ocean waves, you can find it here. And take the ocean with you anywhere you go. I'm trying to think if I was like that that organization that made those videos, what would the catchphrase be? Just take a 5-minute break from the daily rush with our ocean wave timer. Brought to you by YouTube. Watch all the hilarious cat videos you can handle on YouTube. Yeah, there you go. Hey, look at that. What is that right there? That's a little bit of rust. Just a little bit. So, for those of you just joining, um, better late than never, I guess. I don't know. Welcome. Glad to have you. You can always catch the first part, the first 2.5 hours, in the replay, the recording. But we are getting to programming and guessing game. Earlier we installed Rust. We recap. Okay. Started out introductions. We did would you rather only talk like a baby the rest of your life? Or only speak uh like you're reading a telegram the rest of your life? Ooh, I should have thrown in or only speak like you're an auctioneer the rest of your life. That would be a good one. And then talked a little bit about virtual coffee and the Rust learning cohort, because virtual coffee is the organization that I'm a part of. It's an awesome community for people who are into tech, learning about it, working in the industry, just interested, whatever. And my goal this year, I am already familiar with several programming languages. My specialty is Ruby on Rails. I also use JavaScript. I know a couple frameworks there. HTML, CSS, other stuff not coming to mind. And one of my goals for this year is to learn Rust. And there are other people in Virtual Coffee who are also interested in learning Rust. So myself and another member, Andy E., decided to organize a learning cohort, and we got together a curriculum, and you can see it here. Set up a discussion board thing, something where we can do discussion posts and whatnot. And we're working through it. And I'm egregiously behind. So today, installed Rust, did a Hello World, 2 Hello World programs, one with Rust using the Rust C compiler, one using Cargo. And now, and it took a quick 5-minute break while you all enjoyed some ocean waves. Now we're getting into programming a guessing game. Oh, and Rad is just in time. Hello, Rad. Thanks for joining. So, yeah, we are gonna get at that right now. I CD'd into my Super Meg Learning Projects directory and am ready. We're going to learn how let match methods, associated functions, external crates. Oh, we're going to learn about let match methods, associated functions, and external crates, and more. In the following chapters, we're going to explore them in detail, but in this chapter, just going through practicing fundamentals. Implement a classic beginner programming problem, a guessing game. Here's how it works. The program will generate a random integer. That's a number, a whole number, between 1 and 100. It will then prompt the player to enter a guess. After a guess is entered, the program will indicate whether the guess is too low or too high. If the guess is correct, the game will print a congratulatory message and exit. Cool. Sounds like my kind of game. I used to tell people that I was really, really good at the card game war in college. It'd be like, wait, what? I'm like, yeah, no, you don't understand. I'm talented at this game. I get some people. They're like, nah, come on, let's go. It's like, okay. So, this is Coke Zero Sugar, and it's been open in my fridge for 2 days. So it's really flat, but I don't like throwing things away. So I just want to finish it so I can open a new one that's fizzy. You didn't need to know that, but I feel like it gives more meaning to this experience for us all. Okay. Let's do cargo. New guessing game. Boop. Created binary application guessing game package. Okay, now we're going to change directory into guessing game. And use my handy dandy little trick from earlier to close this one out. And zoom, zoom, zoom. Is it 3 zooms? I can't remember. We'll see. I think it was 2 zooms. Is that okay? Should I zoom one more in? Let me know. Ooh, you know what I'm gonna do? I just had an idea. Oh, I should zoom one more in. Okay. I'm gonna do something real quick. I'm moving my face. There. Ha. Yes. Okay. So now I can move this down more. And we have a little more space to work with. Cool. Yeah. All right. So we have the main. I guess all of them just start out with hello world. I guess that's pretty safe, you know? Hmm. Let's do. Okay, I'm going to push you origin main. Oh, wait, did I not? Oh, I have to actually make a repository remotely for this. Okay, because I want this to actually go up somewhere. So let's do that first. GitHub. Oh, it's Meg Dash got y'all. Sorry, y'all. Got my GitHub. It's not Meg underscore. Repos, new. Repository name is guessing game. Oh, whoops. That's me. Me. Ooh, glowing rotary phone. That's a great name. Okay. SSH. Okay, so git remote add origin. So git remote. Cool. Now I'm going to boom do what I was going to do before. Git push you origin main. Oh, did I not do it right? Git branch and main. Huh. I did all the steps. Git remote, add origin, git branch. Hold on. Let's see what happens when I refresh. Oh no, it didn't work. Let me make this bigger. Okay, on branch main, no commits yet. Let's just do this. Okay, so create using cargo commit. Okay. So oh, hey Christine. Git push view origin main. Oh, there we go. So it just there wasn't anything committed yet. And I think that's why it was like, Durr. Cool. Now it's up here. Whee! Nice. How do I do? Yeah, okay. Now let's put this down again. Cool. So again, let's look at cargo.toml. Make this a little smaller. Guessing game. Oh, guessing game. Ooh, what are we gonna guess today? Then we have the hello world. Let's see if it works with cargo run. Oh my goodness. Hello back. 2021. So Lex asked in the chat 2021, referring to edition. Yes. Rust releases a new edition every 3 years. So they have 2015, 2018, and 2021. And this year, a new edition should be coming out. Really though, you're getting, if you update, you're just getting, it's a summary of all the stable releases that come out every 6 weeks. So, We have opinions. I personally do like that. Um, I think it's interesting the way they do that. I mean, it's not, it's kind of like, ooh, a new edition. Oh, wait. It's like, it's all the same. But, oh, hold on. The naming convention. That's, that's a, a useful clarification. Um, I have, I now have fizzy soda update. I now have fizzy soda. Oh yeah. Um, yeah. I didn't throw the flat soda away though. I drank it. Waste not, want not. Oh, whoops. Outdated code sounds weird to me. Um, from oatmeal stream to soda stream. Oh, can't. I'm glad I stopped. Soda stream is taken. Can't say that. So Christine said using outdated code sounds weird to me. So what's actually happening, and that's okay, you weren't here earlier. I'll just go over it again real quick. So the version that's being used right here, it's saying this is the last time it was updated. So excuse me. Rust releases a stable version every 6 weeks, but they have additions every 3 years, which is basically, from what I understand, my little knowledge that I learned from this book so far, they compile changes that had happened in their stable releases into like a summary, and they just like update a lot of uh documentation and guides and things like that. It's like a big, maybe it's more of like a big like effort to get things like crates and other things that go along with cargo like moving along forward, because it I imagine it would be very easy if you have this 6-week release schedule for libraries that support the language to kind of just fall behind and not have like a, like with other languages that have major version releases or minor, like not have those points where it's like, oh, we should think about upgrading to this version, you know? So that's I would imagine that's why, part of the reason they do these editions. But you are getting, so what we're working off of now is up to date. Um, but this is mainly for compatibility, and can find out more here in the book, the editions. Yeah, it's really interesting the way they organize it. Um, that being said, let's So the world said hello again. It always does. Uh, and now, something new. Okay. The first, going, I'm gonna commit generate lock file. Boop, boop. Cool. Shut that down. Now, first part of the guessing game program will be to ask for user input, process that input, and check that the input is in the expected form. Sanitize the input. To start, we'll allow the player to input a guess. Enter the code in listing 2-1. So like I said earlier, I could just copy paste, but since I am learning, I'm going to type it in. And I suggest you all do the same as well. 'Cause that's how you learn. Oh God, I have Copilot on again. Copilot, stop ruining the surprise. I don't want to know what's coming next. I want to be surprised by life. Okay. Guess the number. Okay. And then use STD. Christine, right? Use STD. Yeah. Use STD ::IO. I don't know what that means, but we're gonna find out. In a moment. I know nothing about Rust, so let mute guess. If you notice on the right hand side, certain words have special colors. That's according to syntax. So I'm guessing things like let, mute, use FN. Well, I'm not guessing. I know these are keywords. These are Rust keywords. So it looks like keywords are in purple. This recognizes, I don't think I have keyword highlighting. Like, it knows that it's Rust, but it's not, it's highlighted let and mute, but it's doing it differently, which is interesting. And then here, all the strings are green. And then we have print ln exclamation point is red, as well as string. You learned earlier that this means what comes before it is a macro. So I'm wondering if that means this is a macro. Although I would, just judging from my experience with Ruby and JavaScript, I would guess that this is an object type. Um, but yeah, we shall see. Okay, std in And then for spaces, not tabs. I'm tabbing, but I have a setting in my VS Code that changes tabs to spaces automatically. Let's expect failed to read line, and then print ln. You guessed. Curly brackets. Yes. So curly brackets must mean some sort of interpolation. Looking at this, excuse me. Let's see. Looking at this, we have so the macro print line, we know from just running that cargo run that it'll print out, guess the number, and then please input your guess. Let mute guess, string new. So this is this is me going through this, not knowing any Rust. I'm evaluating this code, making sense of what I think it is before continuing on. I feel like, I don't know, I just want to do it. I think that is a good way to kind of test myself and see where I'm at as far as learning new concepts. Let mute guess equals string new. So I think this is establishing guess as a variable, mute string new. So I think this is saying, okay, we're creating a variable called guess, and it's mutable. So we're allowing the value of guess to change, but it has to be a string. And so this might be like the right now guess is, I don't know, it's just a variable that's a string. And then IO standard in. So use standard IO. This is calling this standard IO package, and this is actually using it in the main function. Standard in, so this is for input through the terminal, and it's saying read line and mute guess dot expect failed to read line. So so this, I think it's telling it like whatever input you get, assign it to guess. But I don't know what because this looks like a failure message. So maybe it's like this expect is like if you can't, if you don't get something, then print this out. Or if, I don't know. I'm not really sure about this. And then this is like, if you do get something, print you guessed, and then whatever was in there. But okay, now let's see what actually this means. Okay, going over it line by line. So to obtain user input and then print the result as an output, we need to bring in the IO, input, output, library and scope. That makes sense. Okay. The IO library comes from the standard library known as std. Okay. So IO is part of standard, and this must be like a signal of inheritance, basically. Like this is IO is contained within std. By default, Rust has a set of items defined in the standard library that it brings into the scope of every program. This set is called the prelude. The prelude. I feel like I should have classical music playing in the background right now. And you can see everything in it in the standard library documentation. If a type you want to use isn't in the prelude, you have to bring that type into scope explicitly with a use statement. Ooh, explicitly. Using the stdio library provides you with a number of useful features, including the ability to accept user input. Okay. The main function is the entry point into the program. The fn syntax declares a new function. The parentheses indicates there are no parameters. The empty parentheses indicates there are no parameters. The curly bracket starts the body of the function. You also learn in chapter 1, print line exclamation is a macro that prints a string to the screen. This code is printing a prompt stating what the game is and requesting input from the user. Okay, here we get to the good stuff. Next, we'll create a variable to store the user input like this. Oh, now the program's getting interesting. I think like a textbook writer. I don't know what to make of that. There's a lot going on in this little line. We use the let statement to create the variable. Here's another example. Let apples equal 5. This line creates a new variable named apples and binds it to the value 5. Okay, I just want to say I like how they word that sentence. Because that's harkening back to my learning JavaScript days. That's something that was drilled into me during this meetup that I would go to. That's really how I. So I went to a online boot camp called Flatiron School, and that's where I met Becca Harwat Weigel, one of the founders of Virtual Coffee, and Flatiron definitely taught us a lot, but I had so much trouble with JavaScript. And when I was at that section, there was very little support for online students. And I found this online meetup um, provided by a different coding boot camp for free. It was at nights, and it was kind of supplementary to their coding boot camp program. The um, that coding boot camp is called Codesmith, and they would walk you through step by step the um, compiling and execution phase of JavaScript. And it just really, I couldn't get a handle on it until I started going to those. And something that they drilled into us for the variables, they, when in a function, you would assign something, you would have like let num equal 10, and we go line by line through a function, and they'd say, what's this line? So that's a variable num equal to 10. And they'd be like, no, this is a variable named num, and they're like reading that it's there, and it's assigned the value 10. Like, it's not equal. This variable is not equal to anything. It's there as a placeholder for a value. And it seems like Rust has this similar concept, like the way they worded it here. It's a new variable named apples and binds it to the value 5. And it's a very like small thing, equal to, but there's a difference. There's um because here, as we read on, in Rust, variables are immutable by default. Meaning once we give the variable a value, the value won't change. So like they're using here, so okay, that makes even more sense. They're using this word binding, like binds. Whereas in JavaScript, for that particular group, they were using like assigning the value. And like with JavaScript, depending on whether they used let or const, that meant different things. Here it looks like to make a variable mutable, we add mute before the variable name. So here it's let or let mute. And that changes whether this value can differ or not. Syntax. Okay, so this is how you make comments in Rust. Interesting. Okay, so returning to the guessing game program, you now know that let mute guess will introduce a mutable variable named guess. Equal sign tells Rust we want to bind something to the variable now. Right, the equal sign is the value that guess is bound to, which is the result of calling string new. Okay, a function that returns a new instance of string. String is string type provided by the standard library. That is a growable UTF-8 encoded bit of text. Growable. Okay. So the colon syntax in the colon new line indicates that new is an associated function of the string type. Associated function is a function that's implemented on a type, in this case, string. Associated function. Okay. This new function creates a new empty string. You'll find a new function on many types because it's a common name for a function that makes a new value of some kind. Okay, so like this, I mean, this is a special function because it's what kicks off the execution, but this is associated on, it's implemented on a type. So it's like attached to a type. So in full, the let mute guess equals string new line is create a mutable variable that is currently bound to a new empty instance of a string. All right. Now we call the standard in function from the IO module, which will allow us to handle user input. So this standard in is a function from this module. Okay, so this function is particular to this module. I wonder if this syntax means that it's a standard in is an associated function of the IO module. Let's see. If we hadn't imported the library at the beginning, Okay. So the standard in function returns an instance of standard IO standard in, which is a type that represents a handle to the standard input of your terminal. A handle. That's interesting. Let's see what that means. This handle implements the read trait. Read line. Okay. So you see how here they have this, and then they call standard in dot read line whatever. Personally, I prefer this. Like at this point in my journey, having on my little rustation diapers with my baby wobbly toddler rustation legs, I prefer to have things as explicit as possible. Here we are calling a function on a module that's being imported up here, and then chaining two more function calls onto it. Um, Whereas we could do this and then that instead, which I think is easier to read. But that's just me. I'm gonna just go by what the book's saying for now. I can always refactor later. Um, and you can bet your ass I'll be singing that song when I refactor. Uh, Next the line, dot read line and mute guess. This looks like some fancy, this and mute, that looks like some fancy stuff. Calls the read line method on the standard input handle to get input from the user. We're also passing and mute guess as the argument to read line. Folks, we've got an argument. Like a Cody one. I mean, these are arguments, the strings, but it's like you put a string in to get print out. You should know what's going to come out of that. Guess the number. This, I don't know. Like, probably something having to do with the guess that you put in. Probably. But this is throwing me off. So there could be some like secret magic in there that I don't know about. Um, mm. So we're also passing and mute guess as the argument to read line to tell it what string to store the input in. Okay, let's see. What's your job, man? The full job of read line is to take whatever the user types into standard input and append that into a string without overwriting its contents. So we therefore pass that string as an argument. The string argument needs to be mutable so the method can change the string's content. So, okay, here we go. The ampersand indicates that this argument is a reference, which gives you a way to let multiple parts of your code access one piece of data without needing to copy that data into memory multiple times. Okay. References are a complex feature, and one of Rust's major advantages is how safe and easy it is to use references. You don't need to know a lot of those details to finish this program. For now, all you need to know is that, like variables, references are immutable by default. Okay. Hence, you need to write and ampersand mute guess rather than ampersand guess to make it mutable. Interesting. Okay. So I want to check this out. Read line. Read line self of locks this handle. Reads a line of input, appending it to the specified buffer. Okay, so ooh, okay, this looks a lot looks pretty similar. Input string new. Read line, mute input. Mm, something bytes read input. Let's see. We're running this. Oh, hold on a sec. Sorry, guys. Let me. Uh, how do I make you bigger? Um, yeah, there you go. Okay, let's try this out. So let's do, I don't know, I'm boring. Test. Okay, so 5 bytes read. Test. Huh, interesting. Um, okay, handling potential failure with result. We're still working we're still working on this line of code. We're now discussing a third line of text, but note that it's still part of a single logical line of code. Next part is this method. Expect failed to read line. We could have written this code as blah. However, one long line is difficult to read. Yes, it is. Keep that in mind, people. Make your stuff easy to read. Future you and your colleagues and people reviewing your code and people who work at places that you used to work will thank you. Fun fact, I reached out to somebody who worked on the team that I work on now. I reached out and connected with him on LinkedIn. And I was like, you don't know me, but I feel like I know you because I read your code like every day. And he's like, yeah, I was really into drying things up, like DRY as in don't repeat yourself. He's like, yeah, I went pretty crazy with that back then. And I was just like, I wasn't gonna say it, but but yeah, it's pretty cool. Like I can't wait to talk to him, pick his brain about like, so what was your strategy here? Like, what were you thinking? He's probably gonna be like, I don't remember, man. I was just learning. But yeah, keep that in mind. You might get a LinkedIn request one day from someone who's like, I feel like I know you because I read your code all the time. And you'll just have to be like, please don't hold that against me. Uh, or maybe that's just me that introduces themselves that way. Um, so let's see. Yes. So please make your code easy to read. Um, Readline puts whatever the user enters into the string we pass to it. It also returns a result value. Result is an enumeration, often called an enum. We have these in Ruby, which is a type that can be in one of multiple possible states. Oh, we don't have these in Ruby. We have something called this, but it is something else, I think. Let's see. Oops, not that. Don't want that. Yeah, definitely something else in Ruby. Um, this looks like a promise. Enum result. Okay. Error. A type that represents either success or failure. Huh. Interesting. Oh my god, I just had a thought. Okay, so for all you JavaScript people out there, this to me this looks like a akin to a promise. Um but the thought I just had, we were earlier talking about like programmer nicknames and stuff like Pythonistas and Rustaceans and Rubyists. I don't know if JavaScript people have a nickname, but you know how how Taylor Swift fans are Swifties? I think JavaScript programmers should be Scripties. Quote me on that. Scripties. Let's start this, y'all. Let's make it happen. Okay. Anyway, I'm glad you're still with me, Lex. Oh, and Christine. Great. um, yeah, we call each possible state a variant. Okay. The purpose of these result types to encode error handling information. Results variants are okay and error. And error. It's a sound I make like every time I'm learning something new. Hey, you know what? Glad to be of service. The variant means the operation failed, and contains information about how or why the operation failed. That is very helpful. Values of the result type, like values of any type, have methods defined on them. An instance of the result has an expect method. Ha, okay. That's what we were looking for. Expect method that you can call. If this instance of result is an error value, expect will cause the program to crash and display the message that you passed as an argument to expect. If the readline method returns an error, it would likely be the result of an error coming from the underlying operating system. If this instance of result is an okay value, expect will take the return value that okay is holding and return just that value to you so you can use it. In this case, that value is the number of bytes in the user's input. If you don't call expect, the program will compile, but you'll get a warning. Rust warns that you haven't used the result value returned from readline, indicating the program hasn't handled a possible error. Okay, so let's see. Expect returns the contained okay value. Because this function may panic, its use is generally discouraged. Instead, prefer to use pattern matching and handle the error case explicitly. Panics. Um, wait, is this like a thing? Oh my god. Panic is a thing that Rust does. I think I like this. I think I'm like falling in love with this language. It's like, I don't know. Oh, starts panicking. Help me. Ah. Um, okay, so let's do this. Let's write main function code. And call cargo build. Compiling. Oh no, it built. It built. Everything's a-okay. So cool. Okay, printing values. Print line placeholders. Okay. Aside from the closing curly brackets, there's only one more line to discuss. The last line. This line prints the string that now contains the user's inputs. The set of curly brackets is a placeholder. Think of curly brackets as little crab pinchers that held a place and value. When printing the result of evaluating an expression, place empty curly brackets in the format string, then follow the format string with a comma-separated list of expressions to print in each empty curly bracket placeholder in same order. Okay, printing a variable and the result of an expression in one call would look like that. Oh, that's really interesting. Huh. So let's test the first part of the guessing game. Run it using cargo run. Cargo run. Okay, guess the number. Who wants to guess a number? Any takers? Between 1 and 100. Oh, 7. Oh my God. You guessed 7. We got another one. Let's see. Let's see what happens. You guessed 5. Whoa. Yo, you guys, we're so good at this game. So good. Okay. Oh, wait. We're not done yet. Damn. Okay. So next we need to generate a secret number that the user will try to guess. Hmm. The secret number should be different every time, so the game's fun to play more than once. Duh. Use a random number between 1 and 100. Rust doesn't yet include random number functionality in its standard library. However, the Rust team does provide a rand crate with said functionality. There we go. We're going to pull in a crate, y'all. Let's load it up on that boat. Get ready. Get ready to ship it out. A crate is a collection of Rust source files. The project we've been building is a binary crate, which is an executable. The rand crate is a library crate, which contains code that's intended to be used in other programs and can't be executed on its own. Okay. Cargo's coordination of external crates is where Cargo really shines. Before we can write code that uses rand, we need to modify the cargo.toml file to include the rand crate as a dependency. Open that file now. Add the following line to the bottom. Sure, specify rand exactly as we have here with this version number, or the code examples in this tutorial may not work. Okay. Everything that follows a header is part of that section that continues until another section starts. So we specify the crates in the semantic version specifier. The specifier 0.8.5 is actually shorthand for caret 0.8.5, which means any version that's at least 0.8.5 but below 0.9.0. Now, without changing any of the code, let's build the project as shown. Cargo build. Updating. Now you can see that now. You can see that building. Oh, so they downloaded 5 crates. Rand Core. Rand Cha-Cha. Ah, interesting. So I'm guessing Rand has these other dependencies. We include external dependency. Cargo fetches the latest versions of everything that dependency needs from the registry, which is a copy of data from crates.io. Crates.io is where people in the Rust ecosystem post their open source Rust projects for others to use. Cool. So in this case, although we only listed rand, Cargo also grabbed other crates that rand depends on the work. Yeah, there we go. Rust compiles them, then compiles the project with the dependencies available. So if we immediately run cargo build again, we just get finished. Woo! Cargo also knows that you haven't changed anything about your code. So just exit. Okay, so it just knows when things are changed. Um, oh, I was about to open the lock file, and that's where we're going next. Cool. Because these are what was downloaded. I want to see. So this is what we're making now. Guessing game. Rand is a dependency. Here's Rand. Okay, here's the dependencies. So Rand Cha-Cha, Rand Core. Rand Core dependency, get random, Rand Cha-Cha's dependency, these ones. So it's just like following the chain of dependencies. And what was the libc? Where's get random coming from? Get randoms. Oh, rand core. Okay. So this is like the cargo lock is like the blueprint for it's like the snapshot of your code in this moment. And let's see. Okay, cool. Updating a crate to get a new version. Cargo provides the command update. Okay, so let's do cargo update. That didn't do anything. Maybe I have to commit this. Add brand. Wait. Interesting. This isn't doing what it says it will. We do want to update a crate. Cargo provides the command update, which will ignore the cargo.log file. Figure out all the latest versions that fit. Oh, okay. Cargo will only look for versions greater than 0.8.5 and less than 0.9.0 if the RAND crate has released the two new versions. Ew, let's see. Okay, so I have to update this for that to work. Wait, I want to see what happens when I put the carrot here. Nothing. Okay. Wow, Edward. Very great contribution you made. Okay, let's try this again. Let me push this down so we can see. Okay, so I updated RAND to 0.9.0. Let's see what happens. Whoa! Ugh. Okay. Error. Um, failed to select a version. Why is this saying they have a 0.8.6? Hmm. Okay. Where is here we go. Let's check this out. Rand. Rand. Okay. So it looks like 0.8.5 is the latest. I guess that was supposed to be hypothetical. Great. Um, well, that's what documentation will do for you. You go and you check and look at that. Woo! Glad we know now. Cool. Um, so we took a visit to Cargo, the Rand crate said, "Hey there, hey, are you any older than you're telling us?" And I said, "No, you got my age right." So yeah, thanks for letting us know, Rand. It's great. Now we're going to generate a random number by updating. Oh, and hey, look at that. We have something else we can pull in here. Rand range. Uh, guess the number. let secret number equal rand thread range gen range 1 dot dot equals 100. Woo. Oh, okay. Print line. The secret number is secret number. Please input your guess. Blah, 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 blah. Okay. So we added the line use rand range RNG. RNG trait defines methods that random number generators implement, and this trait must be in scope for us to use those methods. So this is a trait. Interesting. Okay. Next, we're adding 2 lines in the middle. And the first line we call the rand thread range function. Gives us the particular random number generator we're going to use, one that is local to the current thread of execution. The thread of execution, the toe. Sorry. I've been streaming for 4 hours. Okay. Okay. I just, okay. Yeah. Toes in the house. Okay, cool. Then we call the genRange method on the random number generator. This method is defined by the range trait that we brought into the scope. GenRange method takes a range expression as an argument and generates a random number in the range. The kind of range expression we're using here takes the form start ... equals n, and it's inclusive on the lower and upper bounds. Nice. I was wondering that. So that means 1 to 100 inclusive, so you can guess 1 or 100. So when they say a number between 1 and 100, they mean a number between 0 and 101, really. Yeah. Okay. Okay. You don't know which traits to use, which methods, functions to call from a crate. So each crate has documentation with instructions for using it. Another neat feature of cargo is that running the cargo doc open command will build documentation provided by... Oh, okay. Let's try this. Cargo doc open. Oh, it's building. Whoa! So this is like, yo, you want random number generator? Here's your random number generator. Here's how to use it. Bow. Ah. Right there. Rand range thread generates a float between 0 and 1. A float means decimal. Floating point decimal. Ooh. Okay, so here's the traits. Ooh. Interesting. That's a nice little feature, cargo dock. And then you could just open that up and read it and hopefully not weep. Okay, the second new line prints the secret number. This is useful while we're developing. Yeah, okay. The obvious. Useful while we're developing, but not while you're playing. Okay, who wants to play? Come on, who wants to play? Guess the number. Someone give me a number. I think we're winning. Okay, someone give me another number. Okay, I'm gonna do it. Ah! No, nothing happened. Okay. Generate a random number. Boom. Let's commit that. Okay. Oh, look it. Look. That's Ferris. Ah. Okay. So we have user input, random number. We can compare them. This code won't compile just yet. Oh, snippity doo-dah. Okay. Oh, look at them going all alphabetical order on us now. Okay. STD, CMP, compare, ordering. I feel like ordering some Chick-fil-A or something. I'm getting hungry. uh, okay, match. Oh, hey, see purple. Purple. That's a keyword, y'all. Guess that CMP and secret number. What do we got? Ordering less. Ooh, okay. In Ruby, this little equals greater than. They call that a hash rocket. It's a weird name, but I don't know. It kind of grew on me. What's a hash rocket? Too small. Ordering greater. Print. Oops, line. To back. And then ordering equal Print line. You win. Woo! I want to throw confetti. Let's learn how to make that happen next. Like your terminal takes over your computer and confetti just falls. I like making a big deal out of the little things. Oh, hey, does anybody see what I messed up? Does anybody see it? Because if you do and you didn't say anything, that's not cool. If you don't, it's okay. Boom, those are commas. So, yeah, that's interesting. Hmm. Um. Oh, I want to click on the crab. Do you do anything crabby? Oh, you just tell me it doesn't compile. Hello, Ferris. Were you named after Ferris Bueller? If so, and then you're one called Dudette Crustacean. You're one cool crustacean. I like that. Alliteration. Every time you can, do it. Mm-hmm. Okay, so we're adding another use statement to bring this type into scope. The ordering type is another enum that has a variance less, greater, and equal. These are the three outcomes that are possible when you compare two values. Then we add 5 new lines at the bottom to use the ordering type. The CMP method compares two values, can be called on anything that can be compared. Anything? Can think of a lot. Like butter side up versus butter side down toast. Compare that, Rust. Takes a reference to whatever you want to compare with. Here it's comparing guess to secret number. Then it returns a variant of the ordering enum we brought into scope with the use statement. Use a match expression to decide what to do next based on which variant of ordering was returned to the call to CMP. Values and guess and secret number. So match. Oop, nope, go back. Okay. A match expression is made up of arms. I have arms. Sorry. You always need a little dance break sometimes. An arm consists of a pattern to match against and the code that should be run if the value given to match fits that arm's pattern. Okay. So it gives a pattern. You can, they're powerful features. You can basically plan for situations in advance. So each arm has a pattern to match up against, and you run it through match. So whatever result like goes into the predetermined arm pattern on. Let's read this again. Okay. Match expressions made up of arms. An arm consists of a pattern to match against in the code that should be run if the value given to match fits that arm's pattern. Okay. Okay, so it's a conditional. Russ takes the value given to match and looks through each arm's pattern in turn. So it's like if this, then that. So if the guess is less than the secret number, the arm leads you to print too small. That's one arm. Each of these lines is an arm. So it's the match expression is like a conditional expression, it seems like, only instead of if else. Like I know in like they have like case statements in Ruby and JavaScript for things like this that have like multiple conditions. I'm thinking, like, let's take, for example, country codes for phone numbers. So if the first X numbers on a telephone are this and that, this is the country the numbers from, and there's way more than just 2 or 3 options to pick from. So that would use a case statement. I'm thinking something like that would probably use a match expression here. But I wonder if they use that for simple things too, because like with Ruby, there's also if else statements where you could say like, bye Lex. You could say like if it's raining outside, bring your an umbrella. Oh, else don't don't bring your umbrella. But yeah, I don't know. We'll have to stick with it and see. Okay. Let's walk through an example with the match expression we use here. Okay. Say the user gets 50. The randomly generated secret number is 38. The code compares them. The method will return. So the guess is compared to the secret number. So the guess is greater than the secret number. 50 is greater than 38. The match expression gets the ordering greater value. It starts checking each arm's pattern. Okay, so this compare returns ordering greater, and then it looks inside the method for being like, okay, which of these patterns is ordering greater? Um, then the associated code executes. Cool. The match expression ends after the first successful match. So that's also something to keep in mind when writing match expressions. If you have like ordering equal, you probably wouldn't want it up top because that is least likely, the chances are 1% that on the first guess someone hits like exact on. So each time this match expression goes off, it's going to have to go through ordering. If you have ordering equal up top, it'll have to go through this one and then arrive either ordering less or ordering greater. So it makes sense to have ordering equal at bottom as the guesser narrows down to the secret number. And with my area code example, if you're doing this for a company based in the US and it's I don't know, you're evaluating numbers for customers that are ordering and signing up through for text message updates or something, and it can be reasonably assumed that a majority of your customers are going to be in North America. So you would probably want to order the United States country code up top, followed by Canada, then Mexico, then like go by, you know, check your orders log and see where things are being mailed out to and go by that. So that when the function evaluates, it has to only like go through a few iterations each time. And then for the outliers, it'll take longer. But if you went alphabetically, like it had US at the very bottom, like it wouldn't make sense. It would take so much longer. Okay, so it's saying this isn't going to compile. Let's try it. Let's watch this fail. Which, hey, this is also useful because in learning a new language, you want to get used to error messages. You want to get used to error messages, tests, learn how to read tests. It can help you so much. Learning how to read tests and error messages, because that's how you debug things. So I'm gonna widen this up a little to help. Okay. And pull it up here for now. So mismatched types. This is telling us exactly where. So $22. Here we go. Line 22. Expect string found integer. Arguments to this method are incorrect. No, expected reference ampersand string, found reference ampersand integer. Oh, ampersand parenthesis or curly brackets integer. No, method defined here. Oh, hey, look at that. It's like telling you, for more information about this error, try Rusty explain this thing. So, hey, let's do that. Woo! Okay. Expected type did not. Let's hold up. Expected type did not match the received type. Erroneous code examples. +1, not a number. Okay, so let's see. X plus 1. Okay, so here, they're assigning I32 to X, and they're adding 1. So they're like, what? This error occurs when expression was used in a place where the compiler expected an expression of a different type. Can occur in several cases, the most common being when matching a function and passing an argument, which has a different type than the matching type in the function declaration. That's like really helpful. Super helpful. Nice. Thanks, Rust, for making helpful error messages. I appreciate you. Let's see. There are mismatched types. Rust has strong static type system. However, it also has type inference. When we wrote let mute guess equals string new, Rust was able to infer that guess should be a string and didn't make us write the type. Secret number, on the other hand, is a number type. A few of Rust's number types can have a value between 1 and 100. I32 is a 32-bit number. U32 is an unsigned 30. Jesus. Okay. Unless otherwise specified, Rust defaults to an I32, which is the type of secret number, unless you add type information elsewhere that will cause Rust to infer different numerical type. Okay, the reason for the error is that Rust cannot compare a string and a number type. So we want to convert the string the program reads as input into a real number type. That makes sense. So we got to add something here. Let guess U32 equal S dot trim dot parse dot expect please type a number. Okay, so trim parse expect. Trim gets rid of white space, I'm pretty sure. parse. I'm not really sure. Let me look. I'm going to do this. I'm going to put new lines in here because I know that, oops, this is starting to wrap. Hopefully, oh, that one's still, whatever. Hopefully it's a little easier to read that way. Okay. We create a variable named guess, but wait, doesn't the program already have a variable named guess? Yeah, but hopefully, yeah, it does. Hopefully, Rust allows us to shadow the previous value of guess with a new one. Shadow, ooh, it sounds mysterious. Shadowing lets us reuse the guess variable name rather than forcing us to create two unique variables. Okay. So it's often used when you want to convert a value from one type to another type. We bind this new variable to the expression guess.trim.parse. The guess is the expression. The guess in the expression refers to the original guess variable that contained the input as a string. Trim method on string instance eliminates white space at the beginning and end, which we must do to be able to compare the string to the U32, which can only contain numerical data. The user must press enter to satisfy read line and input their guess, which adds a new line character to the string. Okay, so that's why there's the parse. Oh no, that's why that's for the trim as well. Okay, so if the user types 5, presses enter, guess looks like this. 5 with a new line. On Windows, pressing enter results in a carriage return in a new line. Please, carriage, return. I forgot something at home. I need my carriage to return. Oh, Windows, so regal and elegant. Parse method in strings converts a string to another type. There we go. Convert from a string to a number. We tell it using the colon. A few built-in number types. U32 seen here is an unsigned 32-bit integer. It's a good default choice for a small positive integer. Yeah, it's a good choice. Good default for a small positive integer. Yeah. Okay, cool. And comparing it with secret number, it infers that secret number will be a U32 as well. So the comparison will be between two values of the same type. The parse method will only work on characters that can logically be converted into numbers, which is why we have the expect to handle the error. The error's back to yell at them. Please type a number. Okay, so let's see. Cargo run. Secret number is 40. Let's go. Oh no, too big. 51. Uh, Cargo run. What about 4? Too small. I want to change the other one to the it's just right. Like Goldilocks and the Three Bears. 56. Oh, I win. Yay. Um Now I got a loop. Loop the loop. Oop. Oop the oop. Oop. Oop oop. Okay. Um what do I want to do? Get and uh uh I'm staging things. Ooh, no. Let's split that. Okay. Right. Oops. Whoa, what did I do here? I messed something up. Um, yes. Let's split that. Um, no. Yes. Okay, good. That's what I wanted. Okay. Uh, compare. Compare yes to secret number. So committing that work. And then what's left is this. Convert guess to string. Wait. Boop. Cool. All right. Now looping. Ooh, loop, loop, loop. Loop keyword creates an infinite loop. So we add loop, not lop, not lopping anything. And gonna move this all woo, into the loop. Yeah, it's an infinite loop. The user can't quit. Uh, Typing quit will quit the game. So entering any other non-number. So let's just let's play the game the horrible way. Um, Fargo, run. Woo. Okay, 7. Too small. Okay, let's do 26. Too small. 80. Too big. 66. Too small. 70. Too big. Oh, yay. Oh, no. Get me out of here. Oh, great. Thank you. Um, let's quit. Oh, hey, look at that. We can add a break statement to escape this madness. Oh, print, then break. Another keyword, break. Makes the program exit the loop. Let's do it again. Ugh. Oh my god, 97. Okay, too small, too big. Woohoo! It worked. Nice. And looping for multiple guesses. Heck yeah, look at that. Oh my goodness. Further refine the game's behavior. Rather than crashing the program when the user inputs a non-number, let's make the game ignore a non-number so the user can continue guessing. Okay, we can do that by altering the line where guess is converted from a string to a U32. Oh. Let's guess. Okay, so now this is a match. Interesting. I think I'm going to do that. Match guess.trim parse. Okay. Num. Error. Continue. Okay. We switch from an expect call to a match expression to move from crashing on an error to handling the error. Parse returns a result type, results in enum that has OK and error. We're using a match expression. So these are the arms. And the OK has the data, which would be the guess number. Okay. If parse is able to successfully turn the string into a number, it will turn an OK value that contains the resultant number. Cool. Which will return the number value. If parse is not able to turn the string into a number, it will turn an error value that contains more information about the error. The underscore is a catch-all value. Okay. We want to match all error values no matter what information they have inside them. So the program will execute the second arm's code, continue, which tells the program to go to the next iteration of the loop. Ask for another guess. Okay. Let's see what happens. 3. Okay, so it just gives back. It doesn't tell you it's too big or too small. It just says, input your guess. Tell me. One tiny final tweak. We'll finish the guessing game. Handle in user input error. Commit that. Delete the print line that outputs the secret number. Okay. Delete secret number output. Ooh. Anybody want to play? This is the real McCoy now. None of this hand-holdy stuff. You got what it takes. You got what it takes to guess the secret number between 1 and 100. Okay, let's start with 50. Too small. I'm going about it the most programmer way possible. Cut it in half. 75. Too big. Let's cut that in half. 25 divided by 2. 62. Something like that. I don't know. Too small. Okay, let's go with 68. Too big. Ah, 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 I win. It's 64. 64. Nintendo 64. The squared number when you take 8 and multiply it by 8, you get 64. And when you take 4 hours and 47 minutes and put me in a room with a computer, you get a guessing game and some singing and other things. But hey, look at that! Look at that! Look at that! Look at that right there! What do we do right there? What do we do right there? We programmed a guessing game. That was fun. Lex, I'm so glad that you did not miss that. I'm gonna I'm gonna go get some food and this is going to be published on the Virtual Coffee YouTube channel. So, yeah, I'm gonna live to see this. I don't know. It's gonna live on. Yeah. Anyway, Pip didn't last, but I did, and that's what counts. I'm gonna add some of the interesting things we talked about into I don't know. I'll find a place on the internet to house them and I will add to the description of the published video um where they are and also all the banners and links and probably the intro question just for all you out there watching later on because I want to know where you're from and if you'd rather have to communicate solely in baby talk for the rest of your life or always speak like you're reading a telegram. Stop. So, yeah. Thanks for hanging out with me. I know it was about 2.5 hours longer than I originally planned it to be. Although I didn't originally have a plan, actually, but yeah. And I think there's going to be 2 more project builds in our cohort. I think I probably will stream those live. If anyone who's also in the Rust learning cohort or just a fan of Rust wants to join on the live stream, get in touch and we'll talk about it and see if we can make that happen. Then I won't have to talk to myself so much and make product placement for advertisers we don't have, like Coca-Cola. Drink them while they're fizzy. So much better. Um, that's not a good slogan for Coca-Cola, but it's just an opinion I have. And yeah. Anyway, thanks y'all. See you later.